Let's keep moving on through this unit as we gear up to talk about visual acuity and retinoscopy. Okay guys, in this video we're going to talk about visual acuity types, and we're going to specifically talk about visual acuity types in kids. We're also going to talk about retinoscopy and dynamic retinoscopy, and then we're going to review the use of the stenopapic slit. All right, let's get right into the text. So the first thing we want to talk about is just a couple of different types of acuity types. So the first one here in your text you're going to see is resolution acuity. So whenever you think about resolution acuity, what you want to highlight in your text is the ability to distinguish a pattern from a patch of equal luminance, right? So the reality of this is you're trying to figure out, think of this clinically as a patient that's trying to look at a gray screen and black and white bars, right? And they're trying to tell, well, can they tell it's a gray screen or they can tell that it's just black and white bars? That would be an example of resolution acuity, and that acuity type would be what? Exactly, Teller acuity cards, right? So your Teller acuity cards would be your example of a resolution acuity. You have a gray screen with the equal luminance of a pattern, black and white bar. So can you tell the pattern is there or not? That's one way to measure visual acuity. Another way we're going to talk about is recognition acuity. And this one is one that we're a lot more familiar with, right? Because what type of acuity is a recognition test? That's right, Snellen acuity is a recognition test, right? And what does that do? You want to highlight in the text. That allows us to detect high frequencies, right? So you want to highlight that, right? So Snellen acuity is an example of recognition acuity, and it gives us information about our ability to sense high frequencies, right? With high contrast. All right, next we want to talk about hyperacuity, right? And that's going to be a person's awareness that something is misaligned, right? So whenever you're doing this kind of acuity, you have like two lines, right? And it's like, can the patient tell whether the lines are lined up or whether they're straight over each other, right? And so what type of acuity measure would you be using with that? That's right, vernier acuity, right? So vernier acuity, something we've done in lab. I don't use it very much in clinic, but it is very useful in a certain type of patient population. All right, let's continue on and talk a little bit more about Snellen and what makes a 20/20 Snellen letter. So for that, let's take it to the whiteboard. When you think of 20/20, what comes to mind, right? So whenever you write 20/20 in a chart or you put it in your EHR, right, what are you actually indicating? Well, whenever you think of 20/20, what I want you guys to think of moving forward is you want to think of a distance over a letter size, right? So what does the top 20 tell us? It tells us that we're measuring the patient at 20 feet, right? And they can see a 20 letter size, right? So what if a patient saw 10/20, right? What would that be? That would mean that at 10 feet, they see a 20 letter size. So what we would have to do is that we would have to multiply this times 2, right? To give us the 20-foot equivalent, which would be 20/40, right? Very good. So whenever you think of Snellen acuity, think of a distance over a letter size. So now my next question is, whenever we talk about this 20 letter size, right? What is the definition of a 20 letter size, right? Look to your text, right? So each letter of a 20/20 line on the Snellen acuity chart subtends an angle of a total 5 arc minutes when viewed at 20 feet, right? And it has a detail of 1 arc minute. So now let's draw a picture of an E because I think it'll help illustrate this point. So let's look at the E, and this one makes it really simple because there's 5 distinct bars, right, where you would have light and dark bars on your E on your 20/20 line, right, your TZVECL, right? And if you guys don't have all those memorized with your basic package of what letters are going to be there, you'll get there, right? So whenever we look at the E, what is a 20/20 E, what does a 20/20 E, a letter or a letter size 20 mean? It means that the total size, right, of this letter is going to be 5 arc minutes, right? With the detail, right, each bar of that E is going to be 1 arc minute, right? So now whenever we talk about minimal angle of resolution, right, by definition, and we talk more about this in the low vision section, right? By definition, for a patient to be able to resolve a letter, it has to be 5 times the size of the minimal angle of resolution, right? So the minimal angle of resolution for a 20 letter size would be the detail 1 arc minute, but for us to be able to actually see that it's a letter, it has to be 5 times that size, which is why the total size of a 20/20 letter is going to be 5 arc minutes. Good, let's keep on going and talk about acuity in children. So how do we measure acuity in kids? Sometimes that's easier said than done, right? So for those of you guys that have been in pediatric clinic, you're kind of naming me some different types of acuity tests, and we'll get into those. A couple of ones we have here in the text are going to be the birthday cake slide, tumbling E, Landolt C. The key thing about these are all going to be recognition acuity types. So outside that, you want to write recognition acuity. Now I want to talk a little bit about the Allen Vision test, right? So this is what we're going to do for ages 2 and older, right? So what they do is they name a series of images on a card whenever they view them at close range. Then what you do is you occlude one eye and you take that card and move it away, right? And you find out what is the distance where they can no longer see the shapes on the card, right? And then what you do is you take that distance over 30 and that you can use to convert into your Snellen acuity, right? Sounds kind of complicated. It's why, I'm going to be honest with you, I don't use it a lot in clinic, but it does make for kind of a good optics question. So let's go through an example and talk about that so that we can make sure this is cemented in our mind. Example 6.6 says a child resolves an image at the following distances when examined with the Allen Vision test. What are the acuities for each eye? The right eye, 12 feet is when that card is no longer able to be seen, and the left eye, 20 feet is when that card is no longer able to be seen. So to find this child's acuity, what you're going to do is you're going to take the distance, right, that they could see the card, and you're going to put that over 30, right? And that's going to be able to be converted into their Snellen acuity, right? So to convert that, if you look in the right eye, we're going to take 12 over 30, right? Because at 12 feet, they can see a 30 letter size, right? So what we're going to do is we're going to say, okay, at 20 feet, what letter size do we need? And what we're going to do is we're going to cross multiply. Right? So you're going to take 12x and you're going to take 30 times 20, and whenever you work that out, you're going to get that x is going to be equal to 50. So all it is doing is cross multiplying here, right? You're going to cross multiply. All right, so whenever you do that, you're going to get 50. So what that means is that their equivalent vision at 20 feet would be 20/50, right? So that's the trick. Now on the left eye, they're already at 20 feet, right? So that means that they are 20/30 vision. There's nothing you need to do to be able to convert that to our standard notation, right? So key points with Allen, because like I said, it's not something that we use all the time in clinic. You guys may have used it some recently in your pediatric clinic. If you do, that's going to be great. But if not, right, the key points, whatever distance they see the card, you put that over 30, right? Then to convert that to the 20-foot equivalent, right, all you're going to do is put 12 over 30, and you're going to have 20 over x, you're going to cross multiply. That's going to give you your letter size at 20 feet. And that's going to give you your equivalent visual acuity that we would document at 20 feet. Excellent job, guys. Let's keep on going. Let's continue talking about visual acuity types in kids. We're talking about one of these three are typically going to be the ones that we're going to use normally in clinic with our pediatric patients, right? And that's going to be STICAR, HOTV, and LEA symbol. So particularly at my school, we're an HOTV school, but I know across the nation there are schools that use LEA symbol, some schools use a STICAR. The key point is that all three of these, right, the child is going to have a key that they're going to look at, and they're going to match that to whatever they see up on the screen, right? So whenever we think about these acuity, right, they would be what type of acuity? Yeah, they would be a matching recognition acuity test, right? So all three of these are a matching recognition acuity test. Great job. Let's keep on going. We're going to move into the objective refraction. So we're kind of moving our way through an exam. We start out with acuity. Now we're going to talk about what are some objective ways that we can measure somebody's prescription. First, we're going to talk about everybody's favorite retinoscopy. All right, so a couple of key points about retinoscopy. I know you guys know how to do retinoscopy, so if you forgot, it's going to be in there. The key there is that remember whenever we look at against motion on retinoscopy, that's going to be a myope patient or a myopic patient. Whenever we see with motion, it's going to be a hyperopic patient, right? That's going to be in the box. You can highlight that in case you forgot, right? The key thing there that I think it's a potential for you to mess up is to forget that you're supposed to take out your working distance, right? We do that whenever we're in clinic, but I've noticed even personally whenever I was working these word problems, right? I would sometimes get so wrapped up in the problem, forget to take out my working distance, and you're like, ah, man, I don't want to do that. So just remember, because there's an equation for everything in life, at least in optics-wise, right? You've got an equation here in the book, equation 6.2, so feel free to use that if you need to. It just reminds you that the patient's prescription is the correcting lens minus their working distance, right? And I'll let you guys go through example 6.7 that kind of walks you through doing that exact point, and you'll see that stretched as we go on in the live lecture and in the flashcards and the SMART test. Let's keep on going and talk about one way that retinoscopy can be made a little more challenging, and that's with astigmatism. Right? That's with astigmatism. So the key thing to remember about astigmatism is that whenever you have your streak horizontally, right, what meridian are you actually scoping? Yeah, that's exactly right. You're scoping the vertical meridian, right? So you might want to write that in your text, right? So a horizontal streak, right, is going to scope the vertical meridian, right? And whenever we have our streak vertical, right, what are we actually scoping? We're actually scoping the horizontal meridian, right? So a vertical streak scopes the horizontal meridian. That's not specifically in the text. So I'll just write that out the side. It's a great summary point that we can use. Very good. Let's go through example 6.8. When using retinoscopy on a patient with astigmatism, you can neutralize motion with the vertical streak by using +3 lens. You neutralize motion in the horizontal streak by using a +1 lens. The working distance is 40 centimeters. What prescription is needed for the patient? You guys take a second, pause the video, work the problem out. I'm going to take it to the whiteboard and we'll work it together. So anytime I'm going to do an example, whenever I'm doing a retinoscopy example with astigmatism, I always draw down on power crosses because I just have known in my personal experience too many times I've made little mistakes that have cost me points whenever I was in school. And even whenever I'm doing retinoscopy, like if I'm doing free retinoscopy with like ret bars and I'm trying to do retinoscopy and they've got astigmatism, I just draw down a power cross right there on a piece of paper because it's easier to do than trying to make the mental note of like where everything's at. So if you guys can do this mentally, great. But for me, I need the power crosses. So what we're going to do, right? We said whenever the streak is vertical, right? Whenever you use neutralize motion with the vertical streak by using +3. So we've got our streak vertical. We're going to be scoping the horizontal meridian. So our +3 is going to go horizontally, and then our -1 is going to go vertically. Don't forget to take out your working distance. So our final answer is we're going to have -150 on the vertical meridian, +50 on the horizontal, which is going to give us +50 -2 axis 180 as our final prescription. All right, guys, so don't skip over these examples. Make sure you work through these whenever you see them on the SMART test and the flashcards, right? You want to dominate these topics. So let's continue on and talk about dynamic retinoscopy. When I think of dynamic retinoscopy, I like to think of measuring the accuracy of accommodation, right? Not only are we going to measure for a potential lag of accommodation or a lead in accommodation, but really what we're doing is we're measuring the accuracy of their accommodation. So let's talk about a couple of those types of dynamic retinoscopy measurements. The first one we're going to talk about is going to be MEM, so the monocular estimation method. So we've got our patient's eye here, right? And so what we're going to do is they're going to be sitting there typically reading something on a card on our retinoscope, right? So we've got a card or we've got shapes that they're going to be reading depending on the age of the patient, right? And so there's 3 places that they can accommodate, right? They can either accommodate at our retinoscope, right? They can accommodate behind our retinoscope, right? Or they can accommodate in front of our retinoscope, right? If they're accommodating behind our retinoscope, right, is that going to be a lag or a lead? Yeah, that's going to be a lag of accommodation, right? So a lag of accommodation. What about if they are focusing in front of our retinoscope, right? That's going to be a lead in accommodation, right? So lag of accommodation, they're going to be focusing behind the retinoscope. Lead in accommodation, they're going to be focusing in front of the retinoscope. Another dynamic retinoscopy method we want to talk about is going to be Knott's method of retinoscopy, all right? And so in this case, what you're going to do is the patient's going to be looking at a demand card. They're going to be reading the letters off that demand card or shapes. And what you're going to do is you're going to be moving your retinoscope, right, in and out to get neutrality, right? So if you find neutrality behind the demand card, okay, so you find neutrality here, you're going to be getting a lag in accommodation, right? If you find neutrality here in front of the demand card, that's going to be giving you a lead in accommodation, right? Now, what's going to happen though is that for you to actually be able to figure out the lag or lead in accommodation, what you're going to have to do is you're going to have to figure out what is going to be the dioptric demand at the reading cards. You're going to have to look at the distance the reading card is away from the patient, right? And convert that to its dioptric value. And then you're going to have to figure out wherever you find the lag or the lead, you're going to have to measure that distance to the patient's eye, right? And the difference between those 2 dioptric values is going to be your lag or your lead, right? And so yes, that sounds like a little more complicated situation, doesn't it? And that's exactly why we don't do it very much in clinic, right? But it makes for a really good optics question. That's what you'll see in example 6.10. All right, let's continue on and talk about Mahindra retinoscopy. So Mahindra retinoscopy is also a near retinoscopy measurement. And what it does is there's a couple of key points that I want you guys to know about Mahindra retinoscopy. All right, so I want to talk about Mahindra retinoscopy now. And so Mahindra retinoscopy kind of has some historical context. It's not something that we use a lot now because what it's trying to do is it's trying to measure latent hyperopia. So it's trying to help you measure the refractive status in child and infants. And so it's kind of, think of it as a way to be able to try to measure a kid's prescription without the use of cycloplegic drops, right? Well, now we have cycloplegic drops, and so it allows us to be able to just relax their accommodation. Whenever we don't have a cycloplegic drops, that's where Mahindra anoscopy really comes into play, and it's a really helpful technique. A couple of really important things I want you guys to highlight here in the text. So get your highlighters ready, right? It's performed in the dark at 50 centimeters. It's an unusual technique because it's a monocular technique. The unexamined eye is occluded. And you have this adjustment factor of 1.25 must be subtracted from the subjective component, from the sphere component, the sphere component of the lens powers for you to get your final power. So this kind of works on that concept that whenever we turn out the lights, our accommodative system relaxes, but it doesn't relax fully to distance, right? It just kind of picks a spot out in space. And so that's where that correction factor comes from. It kind of corrects for that lack of full relaxation of accommodation. All right, guys, let's keep on going and talk about the stenopeic slit. All right, guys, now we're moving into subjective refraction techniques, and the first one we want to talk about is the stenopeic slit. So what the stenopeic slit is, you guys look at it and go like, Ryan, I don't remember what the stenopeic slit looks like, right? Well, here's what it looks like. In a trial lens kit, there's going to be a little disc in there that's going to have a vertical opening in it. Well, horizontal, it's got a little slit in it that's an opening, right? That's the stenopeic slit. And so whenever you use this, what you want to think of is a similar concept to pinhole, right? Except what you're doing is you're pinholing a meridian of their eye, right? Either the vertical meridian or the horizontal meridian or any location in between, right? And so a couple of key components I want you guys to think about. Remember, we're not doing retinoscopy, we're doing a subjective test, right? So there's no working distance we have to worry about. With your slit in the vertical position, what you're going to see now that we've drawn this kind of a power cross on here, right, is that you're going to see that there's going to be more of the vertical meridian that's going to be able to go into, light's going to be going into the eye, and almost all of the horizontal meridian is going to be blocked by the stenopeic slit, right? So whenever your slit is vertical, right, you are isolating the vertical meridian in their eye, okay? And what you're going to do to try to neutralize the patient is while you have this slit vertically, right, what you're going to do is you're going to put spherical lenses, either plus lenses or minus lenses, in front of their eye until they say, hey, that makes the world the clearest, right? Whenever you do that, that's going to be the power you're going to put on the vertical aspect of your power cross, right? And then you're going to rotate your slit 90 degrees. You're going to do the same thing for the horizontal aspect of your power cross, right? So that's going to be one key point. Now the other key point is, okay, whenever we're using a stenopeic slit, how do I know whether somebody is just a spherical patient or they've got astigmatism, right? Well, whenever you put the slit in front of the patient, you're going to put it either vertically or horizontally, right? And you're going to say, okay, look at some point in space. You can do this one eye at a time. And you're going to rotate the slit all the way around, right? And if they say the world never gets more clear, never gets more blurry, right, that's going to be a spherical patient. You take the stenopeic slit away, and now you're going to loose lens, trial lens them to figure out what is the best sphere to be able to correct for this patient, right? And it's whenever they say that there's going to be one orientation where the world gets the most clear, right, you've just isolated one of their meridians, okay? And then you're going to take sphere lenses and neutralize that meridian, put it on your power cross, and you can extrapolate that and get the patient's prescription. So stenopeic slit allows us to be able to do a refraction, a kind of a quasi-trial frame refraction with the patient in a situation where maybe you're like at a nursing home or you're like on a mission trip, something like that where you can't use a phoropter, you don't have access to a retinoscope, something like that where you need something else to kind of help you. That's the stenopeic slit. It also makes for a good optics question. So let's go through example 6.12. Consider a patient who sees most clearly with the slit along the 180-degree meridian. With the slit in place at 90, subjective refraction determines that the best sphere is about minus 125. The slit is then rotated 90 degrees and the best sphere is found to be minus a quarter. What is the patient's refractive error? So we'll pause the video, take a second, you can work that out. All right, so now that you've worked that out, you can see on the power cross we'll put minus 125 in the vertical aspect, minus a quarter in the horizontal, and whenever you extrapolate that in minus cell form, we get minus 125, minus 1, axis 180. You just neutralized that patient. All right, guys, you did great on this video. Go dominate the quiz, and I'll see you on the next one.